The mystery of Eratosthenes, how he proved that the earth is round. In the heart of bright Alexandria, under the burning sun of Egypt, lived a special man, Eratosthenes. It was a golden age for Alexandria, a horizon of knowledge where the mind met the universe. The streets of the city vibrated with philosophical conversations, scientific debates, and a mix of cultures that made the air pulse with innovation and progress. Eratosthenes was not only a resident of Alexandria, but also its foremost keeper of knowledge, the chief librarian of the famous Library of Alexandria. This institution was the beating heart of the city, a temple of books, maps, manuscripts, and works of scholars. Its walls housed the knowledge of the ancient world, and Eratosthenes was the guardian of this sanctuary of learning. Eratosthenes was known for his boundless thirst for knowledge. Day after day, he spent his hours studying, reading, and conversing with other scholars. His eyes sparkled with excitement when he discovered a new manuscript or succeeded in deciphering an ancient text. His intelligence was as sharp as a steel blade, and his curiosity knew no bounds. Alexandria was more than a city, it was a microcosm of the entire known world. Scholars from all corners of the known world met here: Greece, Egypt, Persia, India, and many other places. The central square was a vibrant melting pot of ideas, where philosophers, mathematicians, astronomers, and poets shared their knowledge. The Library of Alexandria was not just a collection of books, but a beacon of light for seekers of truth. Here, Eratosthenes felt that he was at the center of the universe, surrounded by the greatest minds of his time. Every day spent in the library was a new adventure, a new path to discovery. A burning curiosity. It was an ordinary day in Alexandria, with the sun slowly rising in the blue sky. Eratosthenes, surrounded by the endless rows of scrolls and books in his library, was interrupted by a messenger. He handed him an old manuscript, coming from a priest in Siena, now Aswan. It was a time-worn document, the writing blurred and the paper yellowed, but its contents were extraordinary. It described an unusual phenomenon observed in Siena. On the day of the summer solstice, objects did not cast shadows. This detail kindled the flame of curiosity in the mind of Eratosthenes. How was it possible that, in a certain place on Earth, objects had no shadows on the longest day of the year? It was a phenomenon that defied common wisdom and his vast knowledge. This anomaly made Eratosthenes wonder if their understanding of the world was incomplete or even wrong. In Alexandria on the same date, Eratosthenes had observed that objects cast shadows, and their angle changed throughout the day. The contrast between the two observations had intrigued him. If the earth was flat, as many believed at the time, the shadows should have been similar regardless of location. But the reality he was observing was different. Eratosthenes began to speculate, perhaps the earth was not flat, but had a different shape. At night, under the starry sky of Alexandria, Eratosthenes spent his hours thinking about this mystery. His theories were bold. If the earth was curved, then it could explain why the shadows were different in Alexandria compared to Siena. It was a revolutionary idea, one that contradicted the conceptions of the time. But to back it up, he needed solid evidence, experiments to prove it. Determined to find out the truth, Eratosthenes began planning an experiment. It was necessary to measure the angle of shadows in Alexandria on the same day of the year when, in Siena, objects did not cast shadows. For this, he needed precise tools and his extensive knowledge of geometry. That day, with a mysterious manuscript in his hand and a revolutionary idea in his mind, Eratosthenes did not know it yet, but he was on the verge of a discovery that would change mankind's understanding of the world in which he lives. Shadows and sunlight, such simple tools, were about to become the key to a fundamental truth about the shape of the earth. First doubts and speculations. Eratosthenes, sitting on a sunny day in Alexandria, noticed how the shadows stretched across the ground, elongated and clear. It was exactly the day of the summer solstice, the time the manuscript mentioned as shadowless in Siena. This discrepancy was not just a minor detail, but an enigma that demanded to be deciphered. In his library, surrounded by books and maps of the known world, Eratosthenes wondered, if the shadows differed so much between Alexandria and Siena, was this not proof that the earth was not flat? The idea that the Earth might be a sphere was beginning to take shape in his mind. It was a theory that contradicted traditional teachings, but Eratosthenes was a man who was not afraid to question accepted knowledge. At night, under the starry sky, Eratosthenes used to meet with other scholars and philosophers. Together, they discussed the cosmos, mathematics, philosophy, and the mysteries of nature. Eratosthenes brought up his idea of the shape of the Earth, causing heated debate. Some viewed him with skepticism, while others were fascinated by his theory. Eratosthenes, with his analytical mind, began to lay the foundations for an experiment. He analyzed the position of the sun, the angles of the shadows, and the distance between Alexandria and Siena. Using his extensive knowledge of geometry, he began to calculate the possible implications of his observations. It was a complicated puzzle, but Eratosthenes was confident that logic and mathematics would lead him to the truth. Although surrounded by skepticism, Eratosthenes' curiosity and determination were not deterred. Instead of simply accepting existing theories, he chose to explore new, unexplored possibilities. He was aware that his discoveries might be met with resistance and even ridicule, but the desire for knowledge was stronger than any obstacle. The experiment. Eratosthenes decided to put his revolutionary theory into practice. To test whether the Earth was indeed curved, he planned a meticulous experiment. He chose the day of the summer solstice, when the sun was highest in the sky, to measure the angle of the shadows in Alexandria, while in Siena the objects did not cast shadows. For measurements, Eratosthenes used a simple but effective tool, a gnomon. This was a vertical stick that cast a shadow on the ground. By measuring the length of the shadow and the height of the gnomon, he could calculate the angle of the sun to the ground. It was a simple but brilliant technique that used the basic principles of geometry. On the day of the solstice, Eratosthenes carefully measured the length of the shadow cast by the gnomon. It was an activity that required precision and patience, each measurement being crucial to the accuracy of his experiment. As the sun rose and set across the firmament, he scrupulously recorded the variations of the shadows. With the data collected, Eratosthenes retired to his library to make the necessary calculations. Using his advanced knowledge of geometry, he calculated the angle formed by the apex of the gnomon's shadow. This was the key to understanding the curvature of the Earth. Focused and methodical, he applied geometric formulas and principles to deduce the precise angle. As the calculations began to reveal the results, Eratosthenes' heart was pounding. He was about to discover something that could change the world's understanding. Excitement and nervousness were entwining in him. If his theories were correct, this would be a defining moment, not just for him, but for the entire scientific world. Distance calculation. With the angle of the shadows determined, the next crucial step for Eratosthenes was to find out the exact distance between Alexandria and Siena. This was an essential element for calculating the circumference of the Earth. Determined to obtain the most accurate data possible, Eratosthenes planned an expedition to measure the distance between the two cities. To measure this distance, Eratosthenes decided to use a standard method of time, step-by-step measurement. He employed a group of bomatists, professional measurers, who were trained to measure distances by counting steps. This method, while seemingly rudimentary, was surprisingly effective and often used in construction projects and geographic research. The bomatists, equipped with instruments for precise measurements and detailed instructions, set out on a long and arduous journey. They passed through burning deserts, past the mighty Nile, through villages and cities. Each step was rigorously counted, turning the journey into a meticulous act of measurement. After an exhausting and painstaking journey, the bomatists returned with the necessary data. They reported that the distance between Alexandria and Siena was about 5,000 stadia. This unit of measurement, used in ancient Greece, was equivalent to the length of the Alexandrian Stadium, giving Eratosthenes a solid basis for his later calculations. Knowing the distance between the two cities, Eratosthenes understood that he now had all the pieces of the puzzle to calculate the circumference of the Earth. This not only supported his theory of the spherical shape of the Earth, but also gave him the opportunity to make a historical calculation that could redefine the geographical understanding of the world. Eratosthenes highlights his perseverance and desire for precision in scientific research. His meticulous work and determination to obtain accurate data is the foundation upon which modern science rests. Through his combination of intellectual curiosity, innovative methods, and unwavering commitment to precision, Eratosthenes not only paved the way for subsequent scientific discoveries, but also set a standard for future research. The revelation. With all the data gathered, Eratosthenes was now ready to take a historic step in understanding the shape of the Earth. This was the moment he had been waiting for, the culmination of his meticulous research and tireless curiosity. In his study, with the scroll spread out before him and the dim light of the oil lamp illuminating the paper, Eratosthenes began to calculate the circumference of the Earth. Using the 7.2-degree angle measured in Alexandria and the distance of 5,000 stadia between Alexandria and Siena, he applied the principles of geometry to make a calculation that would change the world. The calculation was simple but brilliant. If the angle of 7.2 degrees represented 1/50th of a full circle, 360 degrees, then the distance between Alexandria and Siena would also be 1/50th of the total circumference of the Earth. Multiplying the distance of 5,000 stadia by 50, Eratosthenes arrived at a circumference of about 250,000 stadia, a figure remarkably close to modern measurements. This discovery was more than just a mathematical figure. It was proof that the Earth was not flat, but spherical. It was a monumental achievement in the scientific world, a theory that contradicted hundreds of years of assumptions and beliefs. Eratosthenes had not only proved that the Earth was round, but had also provided a method of measuring its entire circumference. Even though his discovery was revolutionary, Eratosthenes faced skepticism and doubt from his contemporaries. Many of the great minds of the time had difficulty accepting this new concept. However, Eratosthenes' determination and confidence in his scientific data remained steadfast. A changed world. Eratosthenes' revelation had a profound impact on the ancient world. Although initially met with skepticism by many contemporaries, gradually the idea that the Earth is spherical began to gain acceptance. His discovery provided a new perspective on how people understood the world in which they lived. Eratosthenes' calculation of the Earth's circumference was not only a mathematical achievement, but had profound implications in the fields of geography, astronomy, and navigation. The realization that they live on a sphere opened up new horizons for explorers and scientists. Maps began to be drawn with a new understanding, and navigators looked at the night sky and seas of the world with a new perspective. In addition to its scientific impact, Eratosthenes' discovery also had a cultural impact. It stimulated curiosity and thirst for knowledge, inspiring future generations of explorers and thinkers. With this new understanding of the shape of the Earth, people began to dream of the possibilities of exploration and discovery beyond the known horizons. Eratosthenes was not content with his discovery alone, shared the knowledge with others. As an educator, he used his calculus to teach students and other scholars about the importance of scientific observation and critical thinking. It has become a model for how science and discovery can be used to enlighten minds and enrich understanding of the world. Although Eratosthenes' instruments and techniques were primitive by modern standards, the accuracy of his calculation remained remarkable. His legacy transcends the era in which he lived, demonstrating the power of scientific thought and unbridled curiosity. Its discovery was a fundamental step in the evolution of human knowledge and paved the way for further advances in science. Eratosthenes is not just about a mathematical calculation, it's about how an idea can change the world. It is the story of a man who saw beyond the limits of his knowledge of time and dared to dream of something bigger. Through his work, Eratosthenes not only changed the understanding of the shape of the Earth, but also helped reshape human thinking about the universe and our place in it. His discovery remains a testament to the courage to ask, explore, and discover.